Alright, I guess I'll show you what I made out of a hoverboard motor. It's an e-bike hub motor. Large torque arm, quick release. Like, not a whole lot of e-bikes that I've seen online have quick releases like this. I think the main reason, I don't know, but maybe it's patented, but who knows. So, yeah. Don't have much of a script to go off of. This motor is laced 200 to a 700C wheel, road bike wheel. The torque arm has a keyway. And the wire goes straight underneath the bearing. I can take this off real quick. Quick release. Hole straight through for the quick release. Yeah, that's a fail. Oh, it actually doesn't want to come off. Okay, there it goes. Torque arm. Because I don't quite have made a keyway cutter some months back, pretty much left it round because it's easier. This is actually the end of a drill bit. It's 1/4 size. You can see milled out a keyway, 1/4 size obviously. It goes straight underneath the bearing. And that's how you get power to the motor. Basically because the housing on this is too thick, I've basically cut it away and used the shrink tube. Because shrink tube is a lot thinner than this thick plastic that they use to cover the wire. And on the other side, you can see this doesn't look like a normal hoverboard motor because it's been machined. I've pretty much, when I had the motor put together, well actually before it was like machined, show you here. See this? This is what it normally looked like before it was machined. So the way I machined it is I took this end of the motor and I clamped it in my jaws, the 4-jaw chuck I have. And then I took these wires and I shorted them together to make sure the motor doesn't spin when it's being cut. So it pretty much sits in the lathe, the chuck, and then the end kind of sticks out and it allows you to machine the face and this upper ridge here. You see, in order to make more room so I can stick in the spokes, I machined this edge around down to be able to make more room on this other one. You can see it's been machined and it has more room. It allows you to drill holes closer to the hub. Yeah, pretty much. This backside I didn't machine down to make it flat because I felt it was like kind of unnecessary. Like when you have like the shaft made and you got it in the motor, you can actually just turn around, stick it in the jaw, be able to hold it out like this and be able to machine it down. But I didn't really want to bother because if you get too much metal in that bearing, you can damage it. I didn't want to risk that, and it was kind of unnecessary for me, like, to cut that down anyway, so it would definitely make more room, but it's definitely unnecessary. Now I gotta put this back together. It's not too hard to put this thing together. But I'm pretty sure a lot of people out there will not know how to work a lathe to get it to work. Get this other stuff together. So it has a set screw to help hold it in place. And that's so it doesn't get, you know, it doesn't start sliding off the shaft. Grab the quick release. Usually it's supposed to go the other way. If I remember. Can go either way, but usually there's always a Pacific side that you want to have it on. And it looks like it's probably the other way, isn't it? Yeah. Now I'm going to show you down over here. The bike. It's always pretty dark in here, obviously, because it's nighttime. Now, the thing about the lever on this, make sure I'm in view. But you definitely want to have this arm in the right spot. Which is great because you can move this around a decent amount. Be able to plug in the connector here and make sure you know where exactly to set it. Now it's kind of set on there. Tighten it down a little more. Now it kind of goes on the bike kind of like a normal hub would. It has the quick releases. Now this, might have to grab this out of the way. Now, one of the main issues with using this kind of motor is that it's its size usually and its RPM. Because this thing would spin at a maximum of like, 600 RPM, which is pretty fast, unfortunately, so how it is. When it comes to holding the, the fork arm to the frame, where is it? Here. You can actually, because the torque arm is so long, you can use something like tape or, a sleeve that you would have on it that would slide on into it and actually hold it in place. Yeah. This is probably not enough tape, but you kind of get the idea. Now, where's the RPM? Alright. Yeah, back at it again. It is quite an interesting motor, for sure, but it's definitely not one of the greatest motors you will want to use. The reason why I didn't grab a normal Ebike motor off the shelf is because hoverboard motors actually spin pretty freely, surprisingly. With no load on them, they spin pretty free. And what I was thinking, because some of the larger hub motors, because they have so much resistance on them when they have no power to them, they eventually at some point you're gonna run out of battery power, and you don't want to be pedaling back against that kind of resistance. So that's why I kind of picked the hoverboard motor, because it just spins freely. Well, almost freely. The other thing about this hoverboard motor is they get pretty hot. I had to dial back the current, or on this, because you can't program this one I got, which, if someone's wondering, if anyone uses these, Like, I hardly see much of a review or videos on this. ESC here. But it's actually a decent ESC. The software is kind of questionable. There are versions of this that are fully unlocked software, but the one I have right now doesn't have a fully unlocked software. It is a programmable, you know, controller. This is what I liked about it, and it's sine wave. If you can hear, as this motor spins up, they're definitely not as, you know, whiny, or you can hear the pulsing in the motor most of the time. You can hear a bit of whining from this. That is actually kind of normal for a lot of sine wave inverters to make some noise like that. And that has to do with kind of like the poles in the actual motor itself. It's not perfectly smooth. But when you're on a load, you hardly ever hear like this buzzing, stepping sound from the motor. Now, the reason why I went with this connector is because I wanted this to be more of a quick release, kind of a e-bike motor. You can get it off. But when it comes to quick release, these are pretty much the connector that pretty much every e-bike enthusiast would go for in order to get into quick release. Pretty quick. You can hear this EC does make a bit of sound, which I'm pretty sure a lot of ECs make a little bit of sound. Pretty much have a cheapo throttle cable here. It's kind of wired up to this, where I took like those pin things, soldered them together, hot glued it, and then shoved in there. Kind of like how I do with all my RC stuff. I pretty much do that all the time. And the reason why I do that is because it's just way more effective. It's quick. You're not like trying to shove a whole bunch of shrink tube on it to keep it from shorting. Yeah. Just have a charger point. The battery here, it's a 48 volt with like 16 amp hour. Not an impressively large battery, but it's good enough. I was hoping for if this motor was more efficient, that you wouldn't be wasting so much energy. But this motor, it's not as efficient as you would think it would be. I'm about to show you what I mean. Make sure the motor can turn on. Put it over. I'll hold it with my toe, if I can. You see at full throttle, you're pretty much drawing like 3 amps, which is not too bad. But when you do this, apparently you reduce your amperage. It's kind of interesting. Holding at a higher RPM apparently draws less amps, but when you're on full throttle, it draws a lot of current. It draws a lot of amps. Now you can see here, I have regenerative braking on this switch, which, you know, helps recuperate like a lot of the current that would be lost when you're decelerating and stuff. It's spinning as fast as it can, and it's actually pretty decent. Then we hit the regenerative braking. It's just about almost pulls 3 amps there, decelerating. That's usually when it's going fast. Like, you have to, because this motor has such high RPM, you have to go pretty quick to get good regenerative braking. So if you're going down a hill pretty hard, pretty fast, you can hit the regenerative braking and it won't actually slow you down as much as some others would, but you can actually recuperate quite a bit of power from the top of the hill to the bottom, depending on your speed. The faster you go, the better it is because of the RPM. But yeah, I just kind of tape it together because that's kind of like how I put my electronics on things sometimes. Is I can remove it pretty quickly. I can reorientate everything real quick, and then once you know exactly where you want to set everything, you can start like bolting it to a surface or so. But yeah, this motor is pretty good. It doesn't pull hard. It gets hot. You can draw more than its rated power, depending on your voltage and what you want to set your controller to. But yeah, I like this design. It's really nice. You can remove it and place it on relatively quickly. I still need to come up with something to be able to hold the quick release this torque arm to the frame, other than this tape, which is kind of hard to do with one-handed. This connector is always on there pretty good, I tell you. What a connector. Once you pull it off, move one side. This one, yeah, like so, comes off quickly. It's not bad. Don't need pretty much any tools to be able to take this on and off. If you get a flat, you're not sitting there fumbling through trying to look for a wrench or something to try to get it off. But yeah, it's a really nice motor. Not as efficient as was like because of, depending on how fast you go. Most of the time you're not going 40 on this thing. I'm pretty sure, if I cut holes in here, cool it down quite a bit, I can, hold 30 miles an hour most of the time if I'm pedaling with it a little. But once it's up to speed, it's actually pretty good. Like I said, when you're only regenerative braking, it doesn't brake hard. It's not really hard at braking regeneratively, which is really nice because then I could sit there and let it charge up the battery going down some hills. Because what I learned from, when it comes to regenerative braking, because of these batteries are not like supercapacitors, or even, this is not even a solid state battery. This is pretty much a normal lithium ion battery chemistry. They're probably like Samsung cells in there. So a longer span of time that you can sit on regenerative braking, the more energy you're going to recuperate. Yeah. But yeah, this is actually a pretty decent motor controller. I would not recommend pulling more than 1,000 watts from it though. It says it goes up to 2,000 watts, but whenever it comes to these motor controllers, you don't really want to be drawing more than half of its rated power, because its top rated power is usually always set pretty damn high, and that's usually ended up doing a short circuit. But yeah. So you're wondering how I cut that? Cut it on a lathe. Harbor Freight mini lathe. I do have a project coming up here in the future. Eventually I want to make like a CNC milling machine, which is going to be a bit of a challenge. But it should be doable. Like, currently I'm getting just a bit low on funds to be able to make something like that. In order to get these off, you're going to need a press, and you're going to need to make a spacer like this, with this cutout right here. A way that you use to cut stuff out is to use a lathe, obviously. But this should be able to fit over the diameter of that space there. Should be able to press it out with a press. See over here. That's my press. Well, I guess this is the end of the video. Pretty much showed you my projects, pretty much. E-bike motor. It's not bad. Could be refined, but you know, maybe even the coils can be rewound to get to run at a lower RPM. But where am I going to find wire for that? I don't know. Maybe. Got future projects. Currently it's a current project, but eventually I would be making a milling machine and hopefully making it CNC, so it's, you know, I can make more complicated parts, you know, without actually having to chuck them in the lathe or, you know, reoriented them like every single time, try to get it, you know, try to make them. Oh yeah, I guess I'll probably show you what this is. So, milling spindle. I think I need a mirror or something behind the camera, but it's pretty much a phone. But you can see here, it's milling spindle, precision spots for the bearings. Has a 20 type thread on it. Has a keyway cut in it. Eventually it's gonna have to be, you know, put into its housing. Its bearings and stuff. And I'll have to make a pulley for this one, so I can spin it with this motor. When you have it spinning with the motor, I can chuck it in a lathe like this on the tail end, be able to cut into it, be able to cut threads on it by connecting it directly to the chuck, and, you know, be able to cut out the taper for ER32, call it. But that would be a project in the future, of course. Stuff like this takes like forever to make most of the time, especially when you have like other things you have to do. So, hope you enjoyed. See you later.